Assalamualaikum. Hello, my name is Amlina Dazni under supervision of Dr. Siti Nur Hafizah binti Muhammad Kazai. Today, I would like to present my final year project titled Transesterification of Palm Oil using CHARACTERIZATION as a heterogeneous catalyst for biodiesel production. So, this is the overview of study. Introduction consists of background of study, problem statement, objective of study. The study was consist of 4, such as catalyst, fossil fuel, biofuel, and lastly, environment. Catalyst, known as catalyst with mechanism actions by lowering the activation energy needed will initiate the reactions. Fossil fuel, petroleum and natural gas as an energy that can be converted to other form to various purpose. Next, biofuels. Biofuel appear as a promising alternative to fossil fuel for diesel engines. Lastly, environment. To develop a solid-based catalyst for efficient biodiesel synthesis by studying the stability of acid catalysts. Problem statement. First, the lower quality of glycerol produced and requirement for purification step in biodiesel production, the catalyst can cover and increase the production cost and dispose problems. Next, heterogeneous catalyst is currently for due to synergistic effect that making them preferable compared to the single catalyst. Objective of study: to synthesize and characterize CHARACTERIZATION as catalyst in the transesterification of palm oil. Next, to find the best reaction conditions such as methanol to oil molar ratio, catalyst amount, and the reaction time to get the highest conversions of biodiesel. For the literature review, first, use of waste source resulting in more cost-effective and environmentally beneficial process. Next, using heterogeneous catalytic has been developed for an environmental friendly and cost-effective process with fuel disposal issue. Furthermore, flowchart for this project. First, we need to prepare feedstock preparation, which is palm oil and CHARACTERIZATION. Step 2 is transesterification of the palm oil with methanol using CHARACTERIZATION catalyst. For the step 3 is optimizations of process, which to determine methanol to oil molar ratio. Next is the reaction and catalyst amount. The last one is the product analyzed by GCFID. Preparation for catalyst. First, preparation calcium oxide catalyst. To wash the eggshell will be washed through with the distilled water several times. Wash eggshell will be dried in the oven at 120 Celsius for 1 hour. Crush into the powder using pestle and mortar. The inner lining and other impurities in the dry shell were removed. Next, preparation for SiO2 catalyst, which is known as the rice husk, was weighed with electronic balance. Then wash with the distilled water to remove any impurity or dirt using conical flask and filter paper. Next, mix with 0.4 molar concentration of hydrochloric acid. Stir for 20 minutes. Heated at 110 Celsius for 3 hours. Rice husks were placed in aluminum crucible and burned at 550 Celsius for 6 hours when dry. Next, for the mixing of CHARACTERIZATION, mix both catalysts using ball milling method with the ratio 1:2. Okay, for the characterization of the catalyst, SAM EDX. SAM used to determine the morphology, size, and surface elements composition of catalyst. EDX will be used to identify the surface elemental composition in the catalyst. Next is the Hamid indicator. Hamid indicator used to determine the basic strength, indicate the phenolphthalein, 2,4-dinitroylene, and the last one is 4-dinitroylene. Furthermore, FTIR used to determine the functional group present in the catalyst. Based on the peak, the functional group and the wavelength can be detected or can be identified. For the transesterification process used to demonstrate the parameter reaction, such as reaction duration, which is time, methanol to oil ratio, catalyst loading, and based on the parameter, the sample will be used to identify the methyl ester. Next, for the methyl ester can be calculated using the following equation. Result and discussion. Firstly is characterizations of the palm oil. 1.2 mg QOH per gram for the acidity value, 65.8 mm² per S for viscosity. Next is 908 kg per cm cube for density. As we know, acid value was used to determine the amount of free fatty acid present in the palm oil. BET result. So for the BET, we will focus on the CaOSiO2. First, lower BET surface area, which 85.77 m² per G due to the catalyst alternations of the metal oxide. Next is the lower pore volume, indicate that CaO impregnate with SiO2. Last but not least, higher pore size will influence catalyst performance of the biodiesel production, which indicate that CaOSiO2 has the highest pore size. For the FTIR spectrum for the SiO2, present of the OH group, a peak corresponding for the bending vibration noticed at 160 for 7.37 cm-1 indicate stretching bond. Next, SiO2 SiO symmetric at the wave number of 567.34 and other peaks indicate the short peak based on the graph. TGA analysis will be determined for alkylsine CaO and SiO. For the alkylsine CaO, we have a three-phase. First phase from 19 Celsius to 616 Celsius indicate the weight loss around 60% based on the curve. Second phase from sharp decline curve which indicate the release of carbon dioxide from calcium carbonate into the calcium oxide. Lastly, the third phase from 816 Celsius to 900 Celsius, which curve remain constant within the temperature range. Okay, for the alkylsine CiO also have a three-phase. First phase will deal with the absorbed water and the mesophore silica-based material. Second, show the difference for the mass percentage. Last is third phase. Mass loss indicate that SiO2 may be interference with the condensations of silanol groups. Same image. A is the alkylsine at CaO, B calcine CaO, C is SiO, and the last one, D is CaOSiO2. Okay, for the CaOSiO2 catalyst using the ratio 2:1, CaO will show a bulky particles separation and the particles are well defined with some elongations occur. For the combinations with the SiO2 form a new shape particles of the mixture and the spacing between the particle become different and increase. Furthermore, for the Hemi indicator indicate that CaOSiO2 is a stronger base catalyst with pH range fall between 9.3 to 15. So the results show phenolphthalein change to the colorless 2,4-dinitroylene turns into reddish orange, 4-dinitroylene remains unchanged. Parameter of this study will be used to determine the effect of the reaction time on biodiesel. So for the reaction time, 1.7 hour used to obtain the highest methyl ester conversion yield, which is 92.94%. Effect of catalyst amount of biodiesel, 5% used to obtain the highest methyl ester conversion yields, which is 92.94%. After that, the effect of methanol to oil ratio on biodiesel, which is 12:1, used to obtain the highest methyl ester, which 92.94%. Lastly, for the result and discussions, 6 methyl ester was detected by the GCFID. The methyl ester was consist of the lauric acid, myrictic acid, palmitic acid, oleic acid, linoleic acid. So, based on this slide, the peak shown in the GCFID. As a conclusion, heterogeneous catalyst from waste biomass, which is calcium oxide from source of dark eggshell and silica oxide from source of the rice husk, was successfully synthesized in producing methyl ester, based on the result and discussion obtained in these studies. Okay, for the recommendation, catalyst should be placed in the desiccator or dry once a week to remove moisture, as catalyst can absorb moisture from the environment. Lastly, a new stir with a digital stirring speed scale can be used to ensure continuous stirring speed of the reaction. That will be effective speed parameter be employed during the reactions. This is the reference for these studies. I think that's all for me. Thank you.